Okay, everyone, last part of our Unit 8 Day 1 notes will be about area of a circle and area of a sector of a circle. So let's begin. So last time we talked about circumference. That was, we said, like perimeter or the distance around a circle. Area of a circle then would mean, the amount of space inside of a circle. And it says, when would you use it? Anytime you have a circular thing, you need to find the area of. If you were trying to surround a tree with a perimeter of fence, you might want to know the amount of area to figure out if you want to put mulch in that circular space. Pizza prices are actually based on area. So even though it'll say this is an 18-inch pizza, that's the diameter, it doesn't really affect the price. The area affects it a little differently. So if you want to get technical and find which coupon's best for your local pizza place, which I may or may not have done before, you would use area. So when would you use it? Pizza, saving money on the pizza, or other situations in which you have a circle. And lastly, what's the formula? So I said this one involves pi, just like circumference did, but it involves r squared. So usually it's pretty easy to remember which formula is which. This has r squared in it, and area is always measured in square units, whereas circumference had not square or linear units. All right, so same pictures from our previous notes, but now you're finding the area of these circles. So notice this is a diameter of 10, and if you recall from last note, a radius is always half that length. So the radius is going to be half of 10, which is 5 meters. And then the area, just like last time too, we'll first plug in pi times 5 squared. Now, you can write either 25, that's 5 squared, pi, and make sure you write square units. Don't forget your units. And secondly, don't just write m. In this case, it's meters squared. Or you can write the decimal answer. It depends what they ask for. Again, this would be in terms of pi or the exact answer. And the decimal would be 78.5. I'd say it's fair to just round to the nearest tenth or 1 decimal, unless you're told otherwise. All right, next question. They already tell you the radius is 9, so you're just going to plug in right away. And that's going to be either 81 pi kilometers squared, or if you multiply those two together, you get 254.5 kilometers squared. All right, so that's area, pretty straightforward. The next thing we're going to talk about is some word problems, if you will, and some of these involve working backwards, particularly examples 2 and 3. And example 1, this is actually similar to what you may have seen on the circumference homework. If it says how much more pizza, anytime you see that, that means you're going to be subtracting. You're going to be finding a difference of some kind, but you don't want to do like 12 minus 10. You actually have to find the area of the 12-inch pizza and the area of the 10-inch pizza, and then subtract those. So first of all, let's switch up the colors. So this is, anytime you see pizza advertised, it is by diameter. So a 12-inch pizza actually has a radius of 6, and a 10-inch pizza has a radius of 5. Now you would find their areas. So if area is pi times radius squared, we would find each of these first. And I'm going to turn these into decimals. Again, you would probably not be talking in real life about a 36 pi inches squared pizza. That sounds kind of weird. So I'm going to multiply this all together and get 113.1. And multiply these together and get 78.5. But now remember what I said. Anytime it says how much more, you're subtracting. So you're going to subtract these two to figure out your answer. So the difference between them, 34.6 square inches, which we write as inches squared. All right. Now, the next two, I said we're working backwards. And the reason why, you were given the area. And in this problem, you are given the circumference. So anytime you're given those to begin with, what I would do is think about your formulas. So if they tell you find the radius, you're not finding area, you're finding r. I would plug in the formula right underneath here. I'd write pi r squared and then equals 324 pi. And what you see really quickly is you have pi on both sides of the equal sign. So that's going to get divided out. Oh, that's a funky looking pi. All right, so we're going to divide that out. That leaves you with r squared equals 324. And now this is just an old school algebra question. You're going to square root both sides. And when you square root that, you end up with 18. So we're going to get 18. Now in this case, because you found radius, you didn't find area, it's a single unit, it's just inches. Like radius is a linear measurement. It would be in inches or feet or centimeters, but area is always square units. So if that was confusing, you could also think of this as technically you had inches squared here, and then you square rooted inches squared, and that left you with inches. Okay, and one more working backwards before we look at the last thing for today's notes, and that would be this problem. So if you forgot circumference's formula, circumference was pi times diameter, and then it says that equals 18 pi. So just like the previous question, you have pi on both sides of the equal sign. That'll divide out, and once you divide that out, you're left with the diameter of 18, and you need to find the area though. So again, sometimes a question won't come right out and say it, but there's more steps than just the first step. So the first step was to get diameter. Now we can turn that into a radius, which is half that amount, and that was millimeters. And then the area would be pi times that 9. And again, if it helps here, if I wrote millimeters, maybe that'll help you remember that's going to be square units, because this is going to be 9 squared, which is 81 pi, and then you're squaring millimeters. So you'll always remember you have square units when you find area. If you wanted to write that as a decimal, you actually already saw this answer earlier in the notes. It was 254.5. All right. So working backwards, we didn't see too many of those with circumference notes, but you did see them here. And the only other thing we have to talk about is kind of like how we did arc length in the previous notes. That was a portion of a circle. This like pi piece is actually called a sector of a circle. It's like a fraction of the area. So just like the previous formula from the notes last time, this has two sets of parentheses. And the first parenthesis is a fraction. It's a fraction of the area. So a sector's area is still going to be the degrees of whatever arc you're looking at. So we're going to put degrees of whatever arc we are looking at. And we always put that over 360 because we are taking a fraction of the 360 and multiplying it by the area of the circle, which is pi r squared. So that formula there is what we're going to use for the next couple examples. And just like you saw with arc length, it's the same fraction. It's always whatever degrees of the arc they're talking about over 360, and then it's either times area, in this case for a sector, or it's times circumference if we were talking about arc length. All right, let's look at these examples below. Now, we're only going to do the first two. So right now, don't worry about C and D. Let's just focus on A and B. So in A's example, I'm finding that orange sector. So remember what we said, if you see a picture like this and they don't tell you, you can assume that's a radius because it's next to ZO, which is a radius. The arc we're talking about has degrees of 72. So the area of our sector in this case is just going to be 72 over 360 times pi times 20 squared. All right, And you want to be careful. Sometimes a question will say, find this arc, you know, the major arc, but it depends. Like if they don't specify, like you can see this is shaded. You knew 72 was the arc that you were looking at. If they had shaded this part, then you would have had to have done like 360 minus 72. Okay, so that said, we can write this either exact or as a decimal. If you do the exact answer, remember, first of all, 20 squared, that's 400. So this is like saying 400 pi times 72 over 360. If you just did the numbers, if you just multiplied 72 over 360 times 400, if you did that over here, you get the number 80. So your answer could have been 80 pi centimeters squared. Now, if they had not said to do it exact, they said you could write a decimal, then you would have had an answer closer to 251.3 centimeters squared. So again, if it's not specified, you can choose either one, whichever is easiest for you. All right, and part B, our last example. No picture, but it says a circle has a diameter of 20. What's the area of a sector bounded by a 280-degree major arc? So you don't even need the picture here. They tell you the measure of the arc. And remember, the only thing I would double check, if it's a diameter of 20, that means you have a radius of 10. So then your area of a sector is going to be 280 over 360 times pi times 10 squared. Now, similar to the previous example, let me pick a different color. If we had done 280 over 360 times 10 squared, which is 100, multiplying those two numbers together, you actually get a weird decimal. So, wrong button. 280 over 360 times 100 is going to give you 77.8. So you could have said the area of this sector was equal to 77.8 pi centimeters squared, but that's kind of weird looking. So if you multiply those two together, you would have an answer of 244.4. And again, it depends what they ask you to find, but hopefully you can see that the hardest part is just organizing everything. Once you get your fraction, once you get pi r squared, the rest is up to you. It's just typing it in. If they ask for exact, you just kind of ignore pi. You pretend it's not there and just work with the numbers around it and then put pi in the answer afterwards. Or if they want it all multiplied together, then just kind of multiply it through. All right, so there you have it. That's the end of Unit 8, Day 1's notes. The homework will talk about both area and area of a sector and a circle. And if you have any questions, you can always let me know. All right, everyone, great job, and best of luck with this assignment.